My TX40 Power Harrow arrived last night. My plan today is to unpack and assemble it, so the first thing is removing the plastic and looking for the instruction manual. I found the manual tucked away here, but after paging through it, I was disappointed to discover that it does not include unpacking and assembly instructions. So the purpose of this video is to provide those instructions. First, I want to cut the straps securing the equipment. Next, I'll cut the straps securing the upper part of the three-point hitch. And finally, I'll cut the straps securing the PTO shaft. The next step is removing the bolt holding the 111-degree point hitch, otherwise known as the part where the lower links attach. Note the lock nut, and then we have a flat washer, 3/4 inch bolt, and another flat washer. Remember these positions because you need to reinstall these bolts in the same manner later on. Now I can remove the bolts from the other side, and again make note of the pattern: lock nut, flat washer, 3/4 inch bolt, and a flat washer. And with the bolts removed, I can remove the lower part of the three-point hitch. I've reached a point where I'm ready to install the upper hitch, but nothing in the manual describes the process. In fact, the picture you see here is the only one. But at least I can see that the upper hitch needs to lean forward toward the tractor. The picture on the front of the manual shows the upper flanges inside the tabs on the body. But as you can see here, one side wants to slide over the tab, while the other side fits inside as required. Trying to squeeze the flanges was just not possible. And in case you're wondering if you can place the flanges on the outside of the tab, the answer is no, for two reasons. First, notice the U-channel hits the corner, making it impossible to align the bolt. Second, you need to install the lower hitch outside the tab. My solution was to use a wood clamp to pull the flanges together. I put one flange on the inside of the tab and inserted 3 bolts and made the nearest bolt snug to keep the flange from popping up. And as you can see, the other flange rests on top of the other tab. So now I'll use the wood clamp to squeeze the flanges. It seems to be working. The flanges are coming together. Now that I have the point hitch flanges inside the tabs, I can install the support bar for the lower hitches. Make sure to put the support bar right side up. The simplest way is to make sure the max RPM sticker faces up. Slide the lower support bar into place, align the holes, and then insert one bolt to hold it in place. Then move to the other side and insert another bolt, and then you can install the 4 remaining bolts. Note that the manual does not provide torque values. With the 3-point hitch parts assembled and the bolts on either side tightened, the next step is installing the category pins. However, I discovered that was problematic because, as you can see here, the angle iron used to secure the equipment to the pallet made it impossible to install the pins. I tried various ways to install the pin, including lifting the equipment, but that proved difficult for one person. So my best option is to remove the angle iron. I used a metal cutting wheel, but a hacksaw works too. After cutting one side, I was able to bend it out of the way. That gave me enough room to move the lower link and to install the category pin. Being able to install the pin and lower the link is necessary in order to be able to lift the equipment from the pallet. The pin secures the PTO bracket, but the bracket must be turned to the horizontal position. And this small cutout is where the PTO shaft rests when not in use. With the left and right pins installed and the lower link arms in place, the next step is to install the upper turnbuckle. Before I could move the equipment off the pallet, I had to bend the angles out of the way to provide enough clearance to pull forward. I discovered the roller would not clear the metal frame, so I adjusted the upper turnbuckle to raise it. That final adjustment allowed me to pull forward without the equipment hanging up on the metal frame. The next step is attaching the PTO shaft. Begin by opening this access panel so you can see the yoke as you slide it onto the spline. In many cases you will need to cut the PTO shaft, and according to the instructions you need to install the shafts so they are parallel as you see here. Place a straight edge against the plastic bell housing. It does not matter which shaft you start with because you will need to mark both to cut them. Then measure back 1.5 inches from the first mark and make a second cut mark. Next, cut the plastic sleeve only. Do not cut the steel shaft. To use the cut-off plastic to mark a cut line on the shaft. Place the plastic sleeve on the shaft, make sure it is flush with the end, and then make a cut mark as you see here. The next step is to repeat the process for the other shaft. Again, place your straight edge against the bell housing, mark the plastic sleeve, and remember to measure back 1.5 inches to mark another cut line. After cutting off the plastic sleeve, use it once again to make a cut mark just as you did on the first shaft. Your goal is to end up with two shafts of equal length that slide together but also do not come apart during operation. I removed the PTO shafts and will cut them in a moment, but before I do, I want to measure the distance between the two splines. I followed the instructions, so I should be okay, but as they say, measure twice, cut once. I want the PTO shaft to be slightly shorter than 24 inches to ensure the two halves do not jam together, which could damage the tractor and the equipment. As they are laid out here, the length from yoke to yoke is about 29 inches. That means I'll have about 5 inches of overlap and about 2 inches of travel when raising and lowering the equipment. Cutting the steel shaft is fairly simple. While you can use a hacksaw, the thin metal cutting wheel makes short work of the task. Be sure to smooth the ends, and then you want to use a file to remove all of the burrs to allow both shafts to slide together with no friction. With the shaft installed, I discovered I could not move the tractor side yoke unless I pushed the equipment side yoke further into the spline. I did not want to have to do that each time, so my solution was to cut another 1/2 inch off each sleeve. I did end up cutting into the warning tag, but not enough to be of concern. Be sure to cut both sleeves equally. And now these sleeves slide far enough to allow me to remove the tractor side yoke, but also still protect the shaft. There are no instructions for installing the safety chain. I looped them around the turnbuckle so they are out of the way while also preventing the sleeves from turning. There are still a few tasks left, but before tackling them, it's a good idea to level the equipment by adjusting the upper turnbuckle. One of the tasks is an initial greasing of the gearbox for each set of teeth. Remove the plastic cover and use a multifunctional lithium-based grease. Be sure to grease all 5. Also be sure to check the oil level in the gearbox. Make sure the equipment is level, then remove the plug. The oil should touch the lower rim of the hole. If necessary, top off the oil using SAE 140 extreme temperature oil. My next task is to move the leveling blade from its current position to the front of the equipment. How do I know that I need to move this blade? Well, let's look at the manual. What we're looking at here is 2 pictures of the same manual. The picture on the left is the manual that arrived with my equipment, and you will note that there is no indication of a leveling blade anywhere in this picture. The picture on the right is the manual that I downloaded from the website, and you can see that this shows the leveling blade has been moved from the rear position to the front of the equipment. So I am going to use this picture as my guide to move the leveling blade on my equipment. To move the blade, I need to remove these 3/4 inch bolts from both sides and then reinstall the bolts on the front of the equipment. While the blade is not that heavy, I found it difficult to remove the bolts, so to make it easier and safer, I used a floor jack and a block of wood to support the blade. And with just a little adjustment of the jack, I was able to remove the bolts with almost no resistance. Now I'm ready to install the blade on the front of the equipment. As I said, the blade is not that heavy, so while you could use the jack and block method, I found it easy to put the blade in place and hold it with one bolt in the top hole. Just be sure that you have a flat washer on the bolt before inserting it. Then it is a simple matter to insert a bolt on the other side to secure the blade. Then you can go ahead and insert the remaining bolts. I've positioned the blade in the lowest position, but if you prefer, you can position the blade higher using the two lower holes on the blade arm. Some of you might have noticed the slots cut into the leveling blade. I noticed them too. I called Tractor Tools Direct and sent them photos. The rep said those marks appear to have been done at the factory. While I don't believe the slots will affect the blade's strength or function, I was concerned about rust. Then I took another look at the pictures from the website. As you can see here, the blade in this picture shows the same slots. So now I don't know whether these slots are a mistake from the factory or they are there by design. And if by design, what is their purpose? I'm waiting for the factory to respond to my inquiry. The last adjustment is the cage roller. Once again, the manual lacks detailed information. I found one line in page 3, the working depth is controlled by the rear roller. And one line in page 4, maximum depth is 7 inches or 16 centimeters. Using these clues, I know each hole represents some increment of a working depth. Since the maximum working depth is the 7 inches and there are 7 holes left, I assume each hole represents some part of the 7-inch increment. To test out my theory, I need to adjust the cage roller. Raising the roller cage to the top hole should give me the maximum working depth of 7 inches. The cage roller is quite heavy, so I will need to brace it and keep it from turning. I used a pair of vice grip clamps on the expander metal to keep it from turning. With the cage prevented from turning, I used a block of wood on the floor jack to lift the cage roller up and down to remove and position the adjustment bolts. Before I can adjust the cage roller up or down, I need to loosen the pivot bolt holding the roll support to the main frame. Note the spacer here. The parts diagram calls it the roll arm push. You want to loosen but not remove the bolt so the roll support can move up and down. The bolt is 3/4 inch. Loosen it about 1 turn, and don't forget to loosen the pivot bolt on the other side. With the pivot bolts loosened, I can move the cage up until the bolt comes out with little resistance. I've already removed the bolt from the other side, so now I can jack up the roll cage until I've reached the desired alignment hole. In my case, I'm using the top hole. When aligned correctly, the adjustment bolt should slip into the hole with no resistance. The manufacturer says the maximum working depth is 7 inches. To test that claim, I put the cage roller in its highest position and placed a level against the bottom of the cage and upper part of the tooth. I also did the same thing with the cage in the lowest position. With the cage in the highest position, my measurement indicated the teeth should, theoretically, cut 7 inches deep. I did the same thing with the cage roller in the lowest position and discovered the teeth are 1 inch below the bottom of the cage roller. That means that each hole on the roller arm adjustment adjusts the cage roller 1 inch per hole. So there you have it, a fully assembled TX40 Power Harrow. It is too wet here in the Northwest to test it. In fact, it won't stop raining now until next spring. So when the weather permits, I'll run the equipment and provide details on how well it works on uneven and rocky ground.